Geotrig, this is lesson, is it 23, day 2. We're going to continue on. We're going to finish up the parent, family, child, bless you, bless you again, for an exponential growth or an exponential decay graph. We ended with just talking about these graphs, about is it a vertical stretch or shrink, is it translated left or right, or translated up or down, and how far in all of those directions. And if A was negative, it would be reflected about the x-axis. Yes? We talked about those things. And we should be able to look at this graph and say it's growth or it's decay. Guys, this one on the board, we ended at last time, is this growth or decay?
Growth.
It's growth. Why?
Because 3 is...
Because 3, okay, whole number, kind of like that. It's bigger than 1. So if your base number, which is the 3, is bigger than 1, therefore we know it's growth. Okay, so just so that we can understand why we say it's a vertical stretch, translated 5 left and 1 down, let's go over that one more time. We say it's a vertical stretch of 2, why? Why is it a vertical stretch of 2? Why is it not a vertical shrink of 2? What's that? It'd be a fraction. Not necessarily. 4/3 would still be a stretch, right? It's bigger than 1. Yes, I like that a little bit better. Most of the time we think of fractions that are less than 1, but we all can make a fraction that is bigger than 1. So 2. 2 is my A value. 2 will tell us 2 different things, actually. 2 will tell us if it's a stretch or a shrink, but since it's 2, bigger than 1, it's a stretch. A, the A value, which is a 2, could also tell us it would be reflected about the x-axis. So instead of opening up, it will open down. But that only happens if it's negative. Okay? Here's the thing. If you don't have to do something about it, you don't state it. Hence, these are the only 3 things that I'm going to do to the equation. I will not state that it's not reflected. I'm not putting extra stuff in. Okay? So therefore, know that. If there was no left or right movement, I would not say there's no left or right movement. I just don't talk about it. Why do we say it's 5 left? And where does it come from? It's plus 5 in the x, right? So it's as the exponent, it's x plus 5. And since it's with x, you know you're going left or right because x's only go left and right. But why is it left 5? It says plus 5. Right. The original problem says it should be x minus h, and the only way to turn it positive is if h was negative. So that's going backwards. So I'm going left 5. And then, at the very end, I have a negative 1, which tells me I'm going 1 down. So does everybody kind of see all of that being done? That's what you were expected to do for all your problems last night. And I asked you guys to write them in a place that stays off to the side so you have room to work. We are now going to, guys, take the information that we asked to put to the side, and we're going to insert that information into the correct proper spot in the parent, family, child method. So here we go. This is our first dabble into the actual full method. And so, first thing I want to do is I want to state what the parent equation is. What is the parent equation to this problem? Y equals 3 to the x. Does everybody agree that the basic problem in this whole thing is y equals 3 to the x power? Yeah. Okay. Now, going back a couple slides, all parents have things in common. There were 3 things that we needed. One of them is what? What's one of those pieces of information that you should have written down for all parents of exponentials? Don't all speak at once, or mumble, as in the top corner there. What is a piece of information that all parents have? We just got this yesterday, guys. It's only a page before what we're doing right now. An asymptote. Y equals 0. They all have an asymptote, a horizontal asymptote at y equals 0. Remember, guys, we talked about the fact that you can't start with something and end up with nothing, right? By using exponents. We also said you can't start from nothing to get something, right? It's not spontaneous generation. I already proved that. Okay. Now, there's two other pieces that we needed.
Family.
No.
Oh.
Information about the parent. How about y-intercept, which is always
0, 1.
0, 1. How do I know it's 0, 1? When I put 0 in for x, it's 3 to the 0 power, and 3 to the 0 power is
0.
1. So therefore 0, 1 does work. I can check that. Then there was that one last piece of information, and that one last piece of information I like to call the extra point. Now the extra point, guys, depends on whether it's what or what? Growth or decay. In this case, we already stated that this graph would be growth. So I'm going to pick a point on the what side? On the right side. Something close to home. So I will pick 1. And if I put 1 in for x, it becomes 3 to the first power, which is 3. Now, what I will do, guys, is we're going to, after we get through this process, I will take and put Desmos on the screen. And we'll actually be able to slide things left, right, up, and down. And I'm going to show you as we change things. Okay? It's not going to be in the video, but we will at least be seeing it live in class. Desmos is a very powerful tool. Now, that's great. We have all this stuff. We have a parent. Now we need to start bringing some of these moving parts back. The first moving part would be the multiplication stuff. So where are we multiplying? We're multiplying with the 2, right? That vertical stretch of 2. So this is what I do. I build a bridge, I call it, to the family. I think of it this way. When you guys are out and about and you are having problems with someone's kid, you don't generally take it upon yourself to take care of the situation because, speaking of, watching other people interact with your own kids, you don't like it when they talk to your kids in a mean way, right? Yeah. You get Mama Bear or Papa Bear coming after you then, saying, why did you just yell at my kid? So, this is the process that you should be handling. Okay, guys? The whole entire equation here is what I call the child equation. If you have a problem with a child, what do? You go talk to the parents. The parents then are going to talk it over and say, oh, maybe we need some help. So who do your parents go to for guidance?
Family.
To the family. And then, from there, you can take care of the child. So that's kind of the process that we're going to do here. Now, if I said we're going to bring back the multiplication parts, that a value, the parent's equation will be 2 times 3 to the x. That's what a family equation. If you think about it, I see it a lot more probably with the guys in here when they go to conferences or meet the teacher night. All of a sudden you look up and you're like, oh, I wonder whose kid this is. And you're like, oh, I know exactly whose kid because they look kind of like mini-me's, right? So It's kind of interesting how that works, but you know that parents and families, or people and families look the same. So there's a family of functions that look like the parent function. And that's what we're building here. We're building it one piece at a time. And here's the cool thing, is that the family is 2 times the parent. Do you guys not see that the parent is still there? Look, this is the parent function right here. It's still there. I'm just taking all of it and multiplying it by 2. Am I changing any x values? No. But if I take an x value, I put it in, right? Figure it out, and then multiply it by 2. I'm taking all the answers, all the y values, and multiplying them by 2. Now, part of this process, guys, and why I had you guys write this down first, is because those words are what go on the bridge. So I want you to say vertical stretch of 2. To complete the process, it's not just enough to have a bunch of random numbers laying around. I want you guys to tell me at each step, what are you doing? Take me on the road map, on the trip to get to the end. And so, as we said, I'm taking basically all of my y values and multiplying them by 2. Multiplying my y's by 2. You don't normally have to write that, but if you want to, write it down. That's what we're doing. So, my y-intercept, guys. And here's the thing. Your y-intercepts and all these different things, they start to change and move. So I actually just get rid of labels now. Labels are gone. Nobody wants to be labeled anyways, right? So, actually, that's not the first thing we talked about. What are the first thing we gave our parent? We gave them the asymptote first. Okay, so if I had a y equals 0, right? And I took my y values and I multiplied them by 2, 0 times 2 is still 0. So y equals 0 still is my asymptote. Okay? Then we move to the point which was, or used to be, our y-intercept. It might not be anymore. But here it is. It's 0, 1. Are we changing the x values? No. So guess what? It stays. But I am taking that y value and multiplying it by, so now it becomes a 2. Then I go to the extra point. Again, I'm not changing the x value, so boom, I can put the x in, but now it's not 3. On the way out, it becomes a 6. All I do from the parent to the family is I multiply all the y values by a. Whatever a is. I could care less if it's a stretch or a shrink or a reflection. If it's a negative 100, I multiply all the y's by negative 100. That's it. Okay? Okay, now that we consulted the family, we go to the child. Okay? The child, guys, is the whole entire equation. Okay? Is everybody okay with this? We got a child equation. There were some things going on. We said because it's x plus 5, we're saying it's translated left 5. We also said we're translated down 1, right? Now, what all this means is that I'm going to take all of the point values, all of the lines, and move them 5 to the left and 1 down. So, here's something really cool. I'm going to add. I'm going to subtract 5 from x and I'm going to subtract 1 from y. That's what I'm doing. So, it's y equals still, but it was at y equals 0. Wait a minute. Y equals 0 is a horizontal line, yes?
Yeah.
If I take a horizontal line and I shift it 5 backwards, did it move it anywhere, really? No. But I'm also going to take that line and move it 1 down. So I'm not at 0 anymore. I'm at -1. I'm going to take the point 2, 0. Or 0, 2, sorry, not 2, 0. 0, 2. If I subtract 5, I'm subtracting 5 from the x's. I started at 0. Subtract 5, I'm at... I start at 2 and go down 1. I'm at 1. If I start at 1, I end up where? -4, down 1, 5. Here's a cool thing, guys. You graph these 3 things, you can draw the curve. Okay, be ready for this?
No.
Okay, I'm going to change colors so we can see the graph. Y equals -1 is a horizontal asymptote, yes? I am going to graph -5, 1, 1, 2, 3, 4, 5, 1, yes? And -4, 5. -4, 1, 2, 3, 4, 1, 2, 3, 4, 5. So what does the graph look like? It looks like that. The graph still is growth, right? It opens up. It's 2 times taller. It's moved to the left 5, but down 1. When I go to graph these, or on your quiz, or in your homework, I am always going to say, using the parent, family, child method, or PFC method. That means you are not allowed to make a table. Boom. I just stated it. It's on video. We are using the parent, family, child.
No, this is considered.
So, we're going to do the same thing with this problem. -3 times 1/3 to the x plus 2 plus 1. I want the parent, family, child to graph this. I will give you guys a couple minutes here first to see how far you can get. This is how we're supposed to do this. Test it out, and then we'll come back together to finish it off. What are some things that are happening? What's going to happen to my graph? Okay, first of all, it's decay. I like that. It's decay. It's opening down, right? I heard that. But we don't want to say open down. We have a better word for that. Reflected about x-axis. What else? It's going up 1. Up 1 and which way? Left 2. Is that everything that is going on with this graph? I would think so. Oh, there's actually, we lost one. Vertical stretch of 3. Vertical stretch of 3. So somebody's stretching this 3 times taller, but yet knocking it over so it goes upside down. Okay? Now we can start the parent, family, child, so we can place everything where it needs to be. Start off with the parent. What is the parent? 1/3 to the x. What are 3 pieces of information. 2 that'll never change and another one will. What's the 2 that don't change?
Y equals 0.
Y equals 0.
Y, or 0, 1.
0, comma 1. And we need an extra point.
And then 1.
Now, the extra point, guys, it really doesn't matter where it is. But again, we're going to be close to home. And since this is a decay problem, the tail will be on the left side. So I'm going to put a point in like -1. Is everybody okay with this? But when I put -1 into the parent, I get 1/3 to the -1 power. What happens with negative exponents? It takes fractions and flips them to give us 3. It's a nice number. Now, if I would have put 1 into here, I would have had to work with 1/3. And then you're going to have to add and subtract from it, all that stuff. Nobody wants to do that, right? Try to keep nice numbers as much as possible. Now we have to go to the family. What is the family equation?
Y equals 3, -3, 1.
-3 times 1/3 to the x power. What of those pieces up in the top corner go on that bridge?
Vertical stretch of 3.
Vertical stretch of 3. What else? Reflected. About x axis. So, here's the cool thing. 2 things are happening, but it's the same A value. I'm still going to multiply what by what? All of the what values, the y values by what? Negative. Last time it was just 2 because A was 2. Now A is -3. I'm going to multiply all of my y values by -3. So it's y equals 0, because 0 times anything is 0. It's not 0, 1, it becomes 0, -3. And -1, comma, -9. Do you notice that your values got larger in the y's, and they all seem to be turning from positive to negatives, aka it's now turned over and it's going down? Very cool. Child. Child. The whole thing, yes? And we're going to say what? We're not there yet. What's on the bridges?
Oh, left to...
Translated left 2. Translated 1 up, or up 1, 1 up, doesn't matter. So now it's not y equals 0, it's y equals 1, because I'm taking all the y values and doing what? What am I doing to all the y values? Adding 1. So it's not -3, it's -2. It's not -9, it's -8. I just did all the y values. Now I can go back to the x values. Am I doing anything there? What am I doing? Subtracting 2. Starts at 0, end at? Starts at -1, -3. I graph y equals 1, -2, -2, -3, -8. You will have the graph. Went a lot faster than the first time, didn't it? going to force this in, I guess. Y equals, I'll change the colors, y equals 1. -2, -2. -3, -8.